Welcome to the online validity slides. So we're going to be building off of the concept of reliability as our first step and then validity as our second step. So just as a quick reminder, when we're looking for reliability, all we're checking for is there statistical evidence that the measure that we've created. So we've created a survey, a questionnaire, a test, a measure that has multiple items, whether when we give that measure or someone uses that measure to rate someone, do we find reliable results? In other words, if it's a stable construct, like personality, like knowledge of a particular field, like ability to do a certain job, that if we have a reliable test, that test should be coming up with the same score over and over again. So, for example, a reliable measure of height would be a ruler that always gives the same height of the same person, no matter who's using the ruler or what process you go through. So 3 different people measure the person, and they all find out he's 6'2", he's 6'2", he's 6'2". That's reliability. The problem is just because a measure is reliable doesn't mean it's valid. Validity is, are we measuring what we think we're measuring? So I can have a highly reliable measure, for example, the ruler to measure height. But if what I think I'm measuring is cognitive ability, in that case, a ruler is a highly reliable, non-valid measure of cognitive ability. A ruler is a highly reliable, valid measure of height. So, using our targets here again, reliable but not valid is we find that when we give the test, we get reliable results. We're always hitting the same area, but we're not hitting the center of the target. We're not actually capturing the construct we are wanting. The next one, going to the right, is low validity and low reliability. So every time we give the measure, we get different scores, even for the same person, and rarely are we actually getting any kind of measures that are near the construct we're trying to measure. Another example of not reliable and not valid is, in this case, we're not even getting near the target in a reliable way. What we're wanting is that final target. We're wanting reliability and validity. We're hitting the target, in this case, the construct we're trying to measure, and we're hitting it reliably. We're going to talk about two different types or we're going to talk about multiple types, actually, of validity. But when we talk about validity, we're really talking about a series of methods, both statistical, but also just common sense and logical and structural, to determine if we truly have validity. We're also going to talk about the multi-trait, multi-method matrix, which combines a fair amount of these techniques into one method to make a stronger argument about validity. So, validity, the definition, a judgment or estimate of how well a test measures what it purports to measure in a particular context. So I love definitions because a good definition gives us all the information to piece apart what's actually going on here. So the first part of this definition, a judgment or estimate. So reliability is often mathematical. We talked about with reliability, for example, that we can look for the correlations between test and retest, alternate forms, split half, complex alpha. All of those are giving us a numerical value that we can use to determine if something's reliable. And in fact, we talked about how both alpha and most of these correlations, what we're looking for is a correlation or an alpha of 0.7 or higher, 0.9 or higher if we're wanting to make an actual decision with that measure. So that's pretty straightforward. When we're looking at validity, though there are some statistical techniques we can use, we're mainly trying to make estimates with those statistics. So we're making an argument that we have validity, or we're making a judgment call. We're using common sense, logic, and maybe even a structured methodology of multiple experts rating whether or not something is valid. But that's what we're doing. We're creating a narrative, an argument. We're going to use multiple methods to argue that we're actually measuring what we think we're measuring. And that's the rest of the definition, that we're basically determining, are we actually capturing the construct we're interested in, measuring what it purports to measure, but that final part of the definition in a particular context. So we kind of talked about that when we validate a slot, when we validate a study or validate a survey or a measure, that we have to be very aware of who was the sample we used to do those tests. That's that context. So if we validate a scale of depression, but the context is we only used 18 to 22-year-old college students, that also tells us how well that validity can generalize to other populations. Validation is the process of gathering and evaluating the evidence about validity. So when we're going through the process of validating a scale, this would almost always follow after we've already tested for reliability. So reliability is our first step. You have to have a reliable scale before you can even find out if you have a valid scale, assuming that you're measuring a stable trait construct. Because if you're not getting reliability, then it doesn't really matter if it's valid or not, because it can't be valid. You're not getting constant responses. So if I'm trying to make an argument that I have a measure of depression, but every time I give it to people, if you're depressed, sometimes you score low and sometimes you score high. And if you're not depressed, sometimes you score low, sometimes you score high. That means that test is unreliable. And since depression should be fairly stable, if someone's depressed, they should score similarly on a depression scale. That means that the question of whether the test is valid or not has already been answered before we use any of these techniques. It wasn't reliable. It probably isn't valid either. If it's reliable, though, that's no guarantee it's valid. So once we have reliability, that's when we're going to start the validation process. Both test developers and test users play a role in validation of a test. So the test developers often will go through a process of actually validating their test before they put it out into the market. But also the test users, and even to some degree the test takers, will often be involved in gathering additional data to make the further claims to build that judgment or estimate of validity. Test users may also validate a test with their own group of test takers, often referred to as local validation. So for instance, if you buy a measure that is meant to be a reading test that has been validated with a national sample, if you start applying it to a small rural sample, you may want to make sure that the test is actually valid for what you're using it for. Also, if your validation, again, that top definition, measure in a particular context, if the sample used to validate a measure you're using was, again, college students, and you want to use it with retirees, you may, again, want to do an additional validation. Does this measure still capture what it's meant to capture in my new sample, a local validation? So validity is whether a test measures what it's intended to measure. So similar, the questions validity is often trying to answer is, for example, does the Beck depression inventory really measure depression? So the first one is these are the arguments we're going to try to make. We're going to try to use methods and statistics and also just systematic thinking about it, honestly, judgment calls of, do we actually have a measure that seems to be capturing the concept or construct of interest? Additionally, do ability tests measure several kinds of intelligence, or is it limited to memory? So not only are we wanting to ask the question, are we measuring the construct we're interested in, we also want to ask, are we measuring it the way we think we're measuring? Are we capturing all of it or a small portion of it? How well does depression scales discriminate from anxiety scales? So another part of validity is not just proving that we're measuring what we're thinking we're measuring, for example, a depression scale that measures depression, but we also want to use the validation process to make sure that our scale is not capturing other related constructs. And some of this can be done through logic and structured methodology, but sometimes it's also some statistical. So we can compare our depression scale to known depression scales, but we can also compare it to an anxiety scale. We'd expect it to be more highly related with another depression scale and less highly related to an anxiety scale. If we found that pattern, that makes an argument that we can estimate that we have evidence that there is validity. Finally, does my new measure of creativity give the same results as an existing measure? So is there just a comparison? So these last two, does my depression scale discriminate from anxiety scale? That's discriminant validity. So does my scale discriminate the way it should from other scales? And does my new measure of creativity give the same results as an existing measure? That's more convergent. We're trying to determine, does my measure relate highly with other measures? So the first way we can look at validity, and this is more of the judgment call than a statistical call, is construct validity. And what construct validity is an array of methods. It's a methodology, and it should be systematic. All science should be trying to come up with systematic methods to conduct itself. But it's a systematic array of methods used to determine whether a test is measuring what it intends to measure. it's really focused on how well are the variables operationalized. So remember, operationalized is the act of taking a broad concept like depression and then creating specific items. So all of your groups right now are in the process of operationalizing your constructs, what you're interested in measuring, into actual operations, individual questions on a scale. So construct validity is basically, have you asked enough questions, have you operationalized enough items to truly capture the construct of interest? This reminds me of a common fable. It's an Indian fable, and it's about three blind mice that are trying to cross a river. And as they're moving forward, something's blocking their way. And the first mouse goes up, the blind mouse, and feels around and comes back and says, it's a tree. A tree trunk is blocking our way. The next mouse goes up and starts to feel around and comes back and goes, no, it's some kind of bird. It had large wings. I could feel them. The third mouse comes up and starts to feel and comes back and goes, you're both wrong. It's some kind of snake. Each mouse felt a different part of the construct they couldn't completely see. Whenever we're trying to measure a psychological construct, we're like blind mice trying to figure out what's going on. The more data we get, the better we are going to be able to actually understand the construct. So in the mouse fable, they had three variables, three mice feeling different parts of what was blocking the way. The answer, by the way, is it was an elephant. So one mouse felt its leg, one mouse felt its ears, and one mouse felt its trunk. I've always wondered how the mouse that felt the ears actually did that. We'll assume it was a super heroic flying blind mouse. But if the mice had continued to go back over and over again, they would have gotten a bigger and bigger picture of what the object was. So this is kind of like construct validity. We are needing to come up with enough variables that we've operationalized that's really going to capture all that is entailing in what makes up an elephant, or what makes up depression, or what makes up cognitive ability. So the two things that we're worried about in construct validity, and this is more of a logical thought exercise, is the first mistake we can make is called construct underrepresentation. This means that we have not measured enough of the construct. This means we've only felt 3 parts of the animal, or 3 parts of the construct, or whatever that number is, but we're still missing enough information that we really don't have the construct really well represented. So we just don't have enough items. Maybe a more practical example, for example, would be if you're measuring general cognitive ability and all your items measure memory. That would be construct underrepresentation. If you were claiming that all you were measuring was memory, you might have a valid construct. But if you're claiming general cognitive ability, you failed the test of construct validity. You have not asked enough questions. You haven't operationalized enough aspects of cognitive ability to truly make that claim. Construct irrelevance is when we're measuring things that are unrelated to the construct. So again, going to my mouse and elephant example, if one of the mice got off track and actually ended up not feeling the elephant, but feeling something completely unrelated, like a plant nearby, that information would now be irrelevant. They were measuring a different construct. So do we have any items that are measuring something other than the construct of interest? Again, for general cognitive ability, if we had some items that got into whether you were conscientious or not, well, that's a personality trait, and that would be irrelevant to a measure of cognitive ability. So the evidence of construct validity, there's many ways to make these arguments. One of the things we can look for is evidence of homogeneity. Homogeneity simply means sameness. So how uniform a test is in measuring a single concept. And this can also be drawn from actual reliability data. So the more reliable scale, we can start to make an argument that all of these items at least seem to be measuring the same construct. Now that doesn't tell us that it's the construct we think it is, but it's some evidence to build on for validity. Evidence of changes with age. So basically, if we're measuring anything that has expected changes, are we finding those expected changes when we measure it with this scale? So for instance, reading rate. Some constructs expected to change over time. So if we use a measure that we think is measuring the construct of reading ability, we give it to 4-year-olds, 5-year-olds, 6-year-olds, and 7-year-olds, we'd expect to see a little bit of change. We'd expect each age group to do a little better on the test. If we find that, that's evidence, further evidence of construct validity. However, if we found 2nd graders did better than 3rd graders, Fourth graders did worse than second graders, and the best scores were actually fifth graders. That's a little bit more jumbled up. We wouldn't expect that pattern. We might be capturing something other than reading. We'd also look for evidence of post-test and pre-test changes. So again, if we have a measure of reading ability and we give it to people prior to them taking an intensive reading class and after they finish that reading class, we would expect to see a change. And if we're actually measuring reading ability, we'd expect lower scores with the pre-test and higher scores with the post-test. This is another test that we can do with a lot of interventions for therapy. So if we have a measure of depression, we'd expect that people prior to going into therapy, especially if that therapy is a validated therapy itself that has been shown in the past to affect depression, that we would find higher scores on the depression inventory pre-test, and after the therapy, we'd expect to find lower ones in the post-test. Additionally, again for construct validity, we can look for evidence from distinct groups. Scores on a test vary in a predictable way as a function of membership in some groups. So for example, if we have a measure of psychopathology, and we give that checklist to a group of violent prisoners versus people that have never committed a crime, we'd expect the violent prisoners to have higher scores than the people that have never committed a crime. If we give a score, a measure of leadership, and we give it to people that have never had a leadership position or people that are an officer in the military, we'd expect to see higher scores on a leadership measure on people that actually are leaders and have been trained as leaders. This would again be further evidence of construct validity. We can also look at it as called face validity. So face validity is simply the appearance that a test measures its intended target. And this is probably the most judgment call of the methods we can use to try to get at construct validity. It basically simply asks, does the test look like it's measuring personality? So if we have a personality measure and we're basically looking at extroversion, are you outgoing? That looks like a measure of extroversion. Do you have a lot of friends? That looks like a measure of extroversion. So these two would pass the face validity test. Do you have a sibling? Not so much. This one doesn't have as much face validity. Does having or not having sisters and brothers affect your extroversion? It may indirectly do it. It may turn out that we find that people that have larger families tend to also be more extroverted because they have little choice but to adapt to being more social. But again, it has a little less face validity. And finally, are you afraid of thunderstorms? This may have almost no face validity. People would look at that and go, how is that related to being extroverted or introverted? Now, the thing is that it may actually still be related. We may have found empirically, in other words, through research, that when we ask people, are you afraid of thunderstorms? The people that say yes are actually much more likely to be introverted, and the people that say no are much more likely to be extroverted. Now, I don't know if that's the truth or not. I'm just basically making up an example here. But if we did find that, that would be a good example of an item that is valid in the measure of extroversion, but has low face validity. This is a common first step in determining if you have validity of your construct. So basically checking for validation. One of the first things we often do is face validity. And it's one of the things I expect your groups to do. I expect you to look at the items that you develop and ask, are these face valid for what we're wanting to measure? But it's not particularly a good method. You can try to structure it. So for instance, once you have a group of items, you can have a panel of experts rate those items on face validity, and that might get you a little bit more information of whether it's face valid or not. But at the end of the day, it's still just a judgment call. So it's fairly difficult to measure quantitatively how face valid is this item, but it's definitely very easy to understand intuitively. This item looks like it measures what it claims to measure. Now, a final note on face validity is sometimes we want a face valid test. So if you're giving a test to people and you want them to kind of have an idea of what it's measuring and you want them to buy in or endorse the use of this scale. So if you're giving a test that's basically about how well you work on groups and teams, and you're going to use it to determine if someone gets a posting in a work group or team. If it's not face valid, even if it is a valid test, people may react negatively to it. They may go, you asked me a bunch of questions about thunderstorms, and now you say I'm not a group player? What gives? That doesn't make any sense. I don't trust this test because it's not face valid. They probably wouldn't use the term face validity, but it is something to consider. Do you want your measure to be clearly obvious to your test takers, Or are you actually wanting to get away from face validity? You don't want them to know what you're trying to measure. So content validity is another methodological way to ask the question, is the content of this measure actually capturing enough ideas or enough variables? So content validity is, again, a judgment call. Now, we can, again, structure it. You can have experts basically weigh in of, do you have enough items to cover the entire content? But the definition here, again, is content validity is how well the test samples the content in the domain of interest. So does a personality test sample a variety of traits? So if you have a personality test and all it measures is extroversion, that is not a very content valid test because you're claiming it's a total personality test. If you took a class on U.S. history from 1776 to modern day, but the test only covered the Civil War, again, that would be a bad example of content validity. Now, if you actually took a class and all the class was about was the Civil War and the test only covered the Civil War, suddenly you have content validity again, assuming that the actual questions about the Civil War, again, cover all the areas of interest. Now, content validity is often dependent on how important each concept of that construct is to what you're actually testing. So let's go back to that history class. Let's actually say that in the history class, you spent 1 week covering history from 1776 to the Civil War. You spent 4 weeks on the Civil War, and then you spent 1 week post-Civil War to modern day. A content-valid history test would then be 1/6 about history up to the Civil War, 1/6 history after the Civil War, and 4/6 of that test should be items about the Civil War. So we're asking how much information was covered, and are we adequately sampling what was covered in the items we're asking. So is the same proportion of tested material the same as the proportion of taught material? Now, again, there's ways to make this a little bit less of a judgment call. Loshi in 1975 came up with an entire system of using expert raters to basically generate a large pool of items to create the content, and then having experts rate each item on how well it represents the construct and whether or not it is essential to measuring it. And then you gather all of those raters' scores, and you take the very top ratings to create a smaller sample out of the pool. Another way to do this just individually is often referred to as just a test blueprint. So when you're creating a test, whether it's a measure of a psychological construct or whether it's simply a test for a class, you create a plan regarding the types of information to be covered by the items, the number of items tapping each area of coverage, and the organization of the items in the test. So for example, when I'm creating a test for a class the very first time, it may be covering 4 lectures. I want to make sure approximately a fourth of each of the questions, so a fourth of the test is from each of those lectures, and that the core concepts that I spent the most time on are the ones that have the most questions, and the ideas that I may have only spent a little bit of time either have a very brief question or maybe I don't even think it's necessary to have a question at all. And that's simply, again, systematically thinking about how you want to lay out your measure, creating a test blueprint.